Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about the antiderivatives of circular trigonometric functions. So the antiderivatives of circular trigonometric functions. So what are circular trigonometric functions? So circular trigonometric functions are of this nature. So let's suppose sine of ax plus b, right? Cosine of ax plus b, and the secant square of ax plus b. So all these kind of functions are nothing but your circular trigonometric function. So I'm going to talk about what is the antiderivative of these functions. So let's go ahead and get started, guys. So the first one, I'm going to be talking about the antiderivative of sine of ax plus b. Now what you got to do first is, as you've seen in the previous video, first of all you got to take care of this part. So what is going to be, you have to make sure that you have to take care of this a, right? So that means you're going to be dividing by 1 by a, and then you will find the antiderivative of sine, which is actually equal to negative cosine of ax plus b, and then you definitely have your c. So that means I can say that the antiderivative of ax plus b dot dx is equal to negative 1 over a cosine of ax plus b plus c. So that is the antiderivative of sine of ax plus b. The next one I'm going to be doing is the antiderivative of cosine of ax plus b. Now again, first of all, you have to take care of this part. That means I'll have to divide by 1 by a. Then again, I have to find the value of antiderivative of cosine, which is going to be sine of ax plus b. And of course, I'm going to be adding c to it. Let's take another example. Let's suppose I want to find out the antiderivative of secant square of ax plus b dot dx. So first of all, I'll take care of this a part. That means it's going to be 1 by a. Then I'm going to be taking care of the secant square part. That will actually give me tangent of ax plus b. All this have been discussed in the previous video, right? So suppose you'll be able to relate to this. Fine. So suppose you're understanding this point over here, guys. Let's suppose if I were to do any question on this, let's say I want to find out the value of antiderivative of sine of 5x plus 2, right? So that actually is going to be, first of all, I'm going to be taking by the 1 by 5 part. Then it's going to be negative of cosine because of the sine of 5x plus 2 plus c, of course. Fine. So I suppose you're understanding this point over here, guys. So let's say I want to find out the antiderivative of this expression over here. So first what will I do is I will first kind of separate this. So this is going to be actually equal to the antiderivative of cosine of pi by 2x dot dx minus 2 over 6x plus 5 dot dx, right? So now if I were to find the antiderivative of this function, first of all I have to take care of this part over here. So that means I'll be saying 2 by pi, which is 1 by reciprocal of this. So the cosine is just going to give me the value of sine pi by 2x minus, so this 2 is actually going to be out because this is actually a constant. Then what I'm going to do is I'm going to take care of this 6 part over here, right? So I'll have to divide by 6, and then since it's 1 over something, so I'll have the value of log of 6x plus 5 plus c. Now this c is actually going to take care of this c and this c because this is a constant. So constant plus constant will always be a constant. So this is going to be the antiderivative of this function. So the property that we've used is that the antiderivative of f of x minus g of x dot dx is actually equal to the antiderivative of f of x minus the antiderivative of g of x. Fine. So suppose you're understanding this point over here, guys. Thank you very much for watching this video. In the next video, we're going to be talking about the antiderivative of exponential functions, right? So this will be about this video, guys. Thank you very much for watching. I'll see you in the next one.